of limited rainfall. Stephen Lerner, Kennis International, Tel Aviv.
To pull the third world into the first, we need to pull more water from the ground. Due to climate change and population and economic growth, by the year 2050, half the land on which grain is currently grown worldwide will be in at-risk locations of water resources. As a Canadian, this concerns me because any wall that threatens beer production is a wall worth breaking. Farmers in developing countries are losing 40% of their yield without even knowing it, which is a shame because the solution is literally right underneath their feet. This is because plants are very inefficient. Most commercial crops only use about 60% of the water available to them to grow. When they sense that soil moisture is at 40% of optimal levels, they close the pores on the surface of their leaves, which stops the flow of water into and out of the plant and prevents nutrient uptake from the ground. The plants stop growing and only maintain a basic metabolic level. Essentially, they hibernate much like bears do in the winter. Plants employ this water management strategy because it ensures, theoretically, their long-term survival. Had they not entered this vegetative state, no pun intended, they would dry up the ground and die. However, in places where water is scarce to begin with, we need to use this 40% for the plants to grow and not have it wasted by evaporation to the atmosphere. So our wall was a literal wall, the physical barrier created by the closed pores of the plant. We needed to find a way to break them. So we made them leaky. To do this, we used a family of proteins called aquaporins. All organisms have aquaporins, which are simply water channels that facilitate the flow of water into and out of cells. Peter Agri, who discovered them, was awarded the Nobel Prize for his work in 2003. In times of water stress, plants turn off the production of these water channels. This stops the flow of water into and out of the plant and stops growth. To prevent this from occurring, we engineered the molecular switch controlling the production of these water channels to stay stuck in the on position. This way, the plant continuously produces these water channels, even below that critical 40% water threshold of soil moisture. As a proof of concept, in field trials with tomatoes which had been turned on, molecularly speaking, we did not notice a difference in yield or quality of fruit between plants given normal irrigation versus those given 50% irrigation. That means that in the future, theoretically, farmers could plant double what they do now while still using the same amount of water resources that they do today. Food is the ABC of GDP. By eradicating malnutrition in children, we enable their immune systems to develop properly. They can stay in school. They can pursue higher education. They are not sick adults who are strains on their country's fragile healthcare systems. And ultimately, hopefully, they can transform their country's economies from being resource-based to technology-driven. In short, give a plant a drink and you feed it for a day. Teach a plant to drink and you can change the world. Thank you.
No question. Thank you very much.